Okay, so now we're doing question 2c. Now this is a parametrics and parabola kind of a question. So we've got a diagram here that shows us a parabola, which is x squared equals 4ay. So we've got many critical points here. We've got r and q, both share the same y value. We've got the chord PR and its y-intercept at u, and we've also got the tangent at q and the tangent at p intersecting at point t. Okay, so we're given this information. We know that p is 2ap, ap squared, and so forth with q and r. We're also given that the equation of PR is y equals half p plus r x minus apr, and the equation of the tangent at p is given by y equals px minus ap squared. Okay, so the first question asks us, part I asks us to find the coordinates of u. So luckily, we are fortunate enough to have the equation of PR already, so we know that PR is given by y equals a half of PR x minus APR. So now since u lies on the y-axis, we know that the x-coordinate of u must be 0. So we're going to let x be equal to 0. So therefore, this whole thing turns to 0, as 0 times anything is 0. And we know that APR also exists. So we now establish that the y-coordinate of u must be minus APR. So we know now that u is 0 and minus APR. Okay, so that's part I done. Now the second part. Show that t, the coordinates of t is given by a, p plus q, comma, a, p, q. Okay, so we're given that t is the intersection of the two tangents of p and q. And now we're given that equation of tangent at p is y equals px minus ap squared. So since they've given us this, I believe it is safe to assume that since p, tangent at p is in terms of p here, we can say that the equation of the tangent at q is just a replacement of p with q. So it must be y equals qx minus aq squared. Alright, so to solve these two simultaneously, we'll get the coordinates of point t. Okay, so we're going to let the first one be 1 and the second one be 2. Now since there is y and y here, we can cancel them out if I subtract 1 from 2. So we take so y minus y will give us 0. And now 1, so we've got px minus ap squared. And this is taken away from, we subtract qx minus aq squared. Okay, so now when we take like terms, we're going to get p minus qx, take away a, p squared minus q squared. And now we'll bring this term over to the other side. So that will give us a, and then we'll perform the difference of two squares here. So that'll be p minus q and p plus q. And on the other side, we've got p minus q here, x. Okay, and now we see there is p minus q here and p minus q there. So those two will cancel out each other. And so now we know that the x-coordinate of t is, as required, a p plus q. Okay, so now if we take this all the way up here, we'll now find the y-coordinate. So all that means is just substituting this value into either 1 or 2. For convenience, we'll choose 1, so we'll get x now equal a p plus q in 1, and therefore we'll say that y equals, where are we, p? Okay, so now when we expand this, we're going to get ap squared plus apq minus ap squared. Again, same thing, take away each other, and therefore we get y equals apq. So therefore you've already found your x and your y coordinates, so it's safe to say that t is indeed the point ap plus q, apq. Alright, so that's the second part done. Now for part 3 of question 2c, we've been asked to show that tu is perpendicular to the axis of the parabola. Okay, so from part 1 and part 2, we know now that t is ap plus q, APQ, and also U is given by 0 minus APR. Now, we've been told that Q and R share the same Y value because they're horizontal to each other. So that must mean that the Y value of Q, which is AQ squared, is also equal to the Y value of R, which is AR squared. So that must mean that Q squared is equal to R squared, or that the absolute value of Q is equal to the absolute value of R. So we can interchange and say that that means that Q is given by minus R or positive R. But since that Q and R lie on opposite sides of the y-axis, Q must be equal to the negative R, because if it was positive, then it would be on the same side of the y-axis, since we know that Q, R, and P are positive integers, or positive numbers, better to say. Okay, so now that we know that Q is equal to minus R, we can now swap U's y-coordinate with minus Q, or Q, because minus R is there. So therefore, we know now that Q is given by 0 minus R AP, which is now equal to 0 APQ. But hey, look, these two share the same Y value now. So similar to chord QR, if these 2 points share the same Y value, then they must be horizontal to each other. They form a horizontal line. T. So if they're horizontal, that must mean they're perpendicular to the y-axis, which is the axis of the parabola.